All right. Hello, everyone. So today we're going to talk about exponential functions. So, exponential functions are of the form y equals a times b, and b is going to be to the x power. That's an exponent, so make sure it looks like that. So we have our a times b and our exponent x here. That is going to give us an exponential function. Sometimes we'll have something added on to the end or subtracted from the end here, but this is the basic form. All right, so let's talk about what we can do with these. So growth or decay. Exponential functions can either exhibit growth or decay and is determined by the value of the base. Base starts with b. Our b is our base here. So this b is going to tell us if we're growing or decaying. That is going to be if our b is greater than 1, it's going to grow. If b is less than 1, it will decay. When it grows, it's going to start out small and then get really, really big really quickly. For b, it's going to be the opposite. It's going to start out really big and then all of a sudden turn small. That is our growth and decay. All of them will look like this unless we have like a negative out front, and that's going to look something like that, but mostly we won't see that. We're going to see these two for growth and decay. Now you're going to notice that these kind of like have a line at the bottom of them, and that's because we have an invisible line right below this, and that's going to be called our asymptote. That's this word here, asymptote. So our functions are going to follow this asymptote line. But what is that? An asymptote? An asymptote is a line that the graph gets close to but does not cross. They will never touch each other. So our asymptote is basically like a boundary line. It's telling our function you cannot pass this line right here. It will get very, 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 very close to it, super, super close, but it won't actually touch it ever. It'll get really close to touching it, but it won't actually cross it. So I'm going to actually highlight that part because it's real important. It gets close, but it does not cross it. Exponential functions have asymptotes of the form y equals a number. So some number where it crosses. Sometimes our asymptote is up here, sometimes it's all the way down here. Most of the time it's usually 0, but we're going to have a number for that asymptote. Okay, so I got some directions down here. Classify each of the following as growth or decay. So once again, we're just going to go to the top of these notes here. If it's growth, our b is going to be greater than 1. If it's decay, our b will be less than 1. Keep in mind that your b will be your base. That is this guy right here that has the x attached to it. Whatever number has x attached to it will be your b. So let's take a look at what we have here. So looking at number 1 first, we have -3 times 2 to the x power. Okay, so since that 2 has the x power attached to it, that is going to be our b. 2 is greater than 1, so we're going to have growth. All right, let's take a look at the next one. F of x equals 1 over 4 times 3 over 4 to the x power. Okay, 3 over 4 has the x attached to it. 3 over 4 is less than 1, so this is going to be decay. All right, keep going. Number 3. Looking at my base, we got 3 over 2 here to the x power plus 4. 3 over 2 is greater than 1, so this is going to be growth. Remember, if you're not sure with the fractions, you can always plug this into a calculator. You just do 3 divided by 2, and that will show you that you have like 1.5, which is greater than 1. So that's how we got that growth. All right, so in class, I had everyone do 4, 5, and 6 on their own. So I'm going to leave that here for the notes as well. I'm going to have y'all fill that in for me. Okay, that is our first page. Not too bad. We're kind of seeing what our function is doing. So let's talk about graphing these because that's going to be part of our, or a big part of our lesson. All right, going to the inside of my notes. It says directions. Graph each of the exponential, graph each exponential function by creating a table of values. This is our table. We're going to create it. And then fill out the given characteristics, and we're going to graph it as well. So I'm going to start with number 7 over here. All right, it says y equals 2 to the x power. Okay. What we're going to do with this is take our function and just write it a bunch of times in our table. We're going to use the same function every single time. The only difference is going to be our x will change depending on what the x's say in this column here. So let's see. I'm going to have 2 to the x, but instead of x, I'm going to replace this with the negative 2 because that's what our x is. It's in that column. So I got negative 2 instead of x here. So that's going to give me 2 to the negative 2 power. And then from here, you're going to solve it. So I have 2 to the negative 2. That is going to be 1 over 2 squared because of that negative exponent rule. And then we got 1 over 2 squared. That's 4. So our first value will be 1 over 4. And then we move on to the next one. So I'm going to do 2 to the x, but instead of x, I want to put our negative 1. That's going to go right there. I'm just going to erase that and put that in. Okay, 2 to the negative 1. I know that since this is a negative exponent, I'm going to flip this. So I got 1 over 2 to the first power. And then 1 over 2 to the first power, that's the same thing as 1 over 2. So that's going to be my next value. Moving right along, I'm going to do the same thing. I got 2 to the x, but instead of x, I'm going to put in a 0. So let's erase that and put in a 0. Okay, our 0 exponent rule tells us that any number to the 0 power will end up being 1. All right, moving right along to the next guy. We got 2 to the x. So instead of x, I'm going to put in a 1. I got just 2 to the first power is just going to be itself. So that's 2. And then we have one more left. 2 to the x, but instead of x, I want 2. So I'm going to erase that, put in a 2. So that's 2 squared. 2 squared is just going to be 4. Now I have my table built. So I have a section of x values, and I have a section of y values that we just found. So those values are going to give me points that I'm going to put on this graph. So let's see what we have. I got x is negative 2. My y for that was 1 over 4. Okay. Next one, I got negative 1, comma, we said 1/2. Next one is 0. Our answer was 1. We got 1. Our answer was 2. And the last one, we had 2, and our answer was 4. All right. So all of these are going to go down into my graph. So I got negative 2 to the first negative 2, comma 1/4. That is our first one. So that's the first thing that's going to go in my table here. Remember your x and your y axes. So I had negative 2, comma 1/4. So I'm going to go over to negative 2, and then I'm going to estimate where 1/4 is. I think it's going to be like right here. Pretty sure it's right there. For these ones that have fractions, you are going to have to approximate or like guess. I mean, make an educated guess. It's not just like, oh, I'm going to put it anywhere. Like you got to kind of see where you are and where that fraction would be. So I'm assuming that's where 1/4 is. And that's my first point. So let's go on to the next one. We have negative 1, comma 1/2. So I'm going to go down here, going to go over to negative 1 and assume 1/2 is right here. Pretty sure. That looks pretty good to me. Making an educated approximation. All right, next one. I have 0, comma 1. Well, that one's a little bit easier because that's going to be exact. So 0, comma 1. I'm going to start at 0 and then go up to 1 right here. All right. Then we're going to go with the next one, 1, comma 2. So I'm going to go over to positive 1 and up 1, 2 right here. boop. And then the last one is 2, 4. So I'm going to go over 1, 2, up 1, 2, 3, 4 right here. Boom. All right. So that was all of the points that I had in my table. So let's just connect our dots here, like so. But with these, I'm going to extend this past my graph. And then I'm going to get really, really, really close to that 0, but I'm not actually going to touch it. So this is where that asymptote part comes in. I know that we started, or rather, we went down from 4 to 2 to 1 to 1/2 to 1/4. If we went past this, it'd be 1/8, and then 1/16, and then 1/32, and then so on and so forth until you're getting really, really, really close. Super, super close to this line, but you will never actually touch it. So our asymptote here is going to be 0, and that's going to be right on the axis. There's an invisible line there that's just like repelling our function. It's not actually going to touch it. It's just going to be extra close. All right, so let's take a look at these characteristics that they asked us for. Okay, first one, growth or decay. Let's take a look. I see that we started out low and then we got really, really high. So that looks like it's growth to me. All right, asymptote was our next one. On the other side of our notes, we said it was of the form y equals a number. Let's see, that number is right on the axis, so that is going to be 0. Y equals 0. All right, now we need our y-intercept. Remember, your y-intercept is where your function crosses the y-axis. This is our y-axis, so we're seeing where it crosses right here. That is at 1. So y-intercept is going to be 1. Domain. Domain we talked about a while ago when we were first starting our functions. The domain is going to ask us how wide our function can get. So looking in this direction, we're just going to keep going because it's got that little arrow. It's just going to go on and on forever. In this direction, we're still going to get wider and wider and wider as it gets bigger. So there's no stopping here, no stopping here. So that means our domain will be all real numbers because it will cover every single number that could possibly be. All real numbers, ARN. For every exponential function we see, the domain will be all real numbers, or ARN, every single time. Okay, and then we have the range here. So if our domain talks about how wide this gets, our range is going to talk about how tall it gets. So looking up here, it looks like it's just going to keep going up. It has this upwards arrow, and there's no stopping it from going up. However, we are being stopped from going down because we have this asymptote here. We can't cross this asymptote, so it's not going to be below this line. It'll only be greater than that line. So for our asymptote, we're going to say y is greater than our asymptote, 0. And that will be our range. So that is our first problem here. You are going to need to build your table, draw the graph, and then fill out your characteristics. Now, I'm going to tell you ahead of time, you could use your table to fill out the characteristics on your own already, but we're going to talk about that more in class. So let's try another one. Let's do number 8 together. So on number 8, I was showing the class how to do this on the calculator. I can't show you the calculator on here, but still follow with me here. I'm just going to use my calculator so that I don't have to do all of this work by hand, okay? So, let's figure out our table. Just like last time, we're going to use the function that they give us. Something different than last time is that instead of y, they're saying f of x. Remember, f of x is just a label. It's just telling you this is a function of x. It basically functions the same way as y. It's just a label. Okay, so I'm going to take my function and I'm going to put it down here. So I have parentheses 1 over 3 to the x power. But remember, instead of x, you want to replace it with whatever x is given to you. So we got -2. I'm going to swap that out for my x. Boop. -2. And I'm going to solve it from here. So to do this, like I said, I'm going to use my calculator. I want to have you do the same thing. So I'm just typing in exactly what's written here into my calculator. I got parentheses, 1 divided by 3, parentheses. And then we have our caret to the -2. Now, if you're not sure what I'm talking about, that is okay. All right. When you come back or when you are in class, please ask me how to do this and I will definitely show you. All right. So I'm just plugging it in here. Let's see. All right. So for this one, I got 9. That is my first value. Like I said, I did this on my calculator. I want you to do it on the calculator as well. Or you can do it by hand. That is fully up to you, but I prefer to use a calculator. All right, next one. Same thing. I got 1 over 3, but instead of x, I want what x is here. That's -1. So, boop, to the -1. I'm going to type that into my calculator. And I got 3 for my answer for this one. And we're going to move right along. I got 1 over 3, but instead of x, I want 0. So I'm going to plug that in and put in 0 equals. And I know for my 0 exponent rule, anything to the 0 power is just going to be 1. So that one we didn't need the calculator for. Usually I only use them when we have like weird stuff going on, like fractions. But yeah, let's move on. I got 1 over 3, parentheses, to the x power, but instead of x, I'm going to put in this 1 here. So I got 1. And anything to the first power is just going to be itself, so that's just 1 over 3. Or if you put this in the calculator, you would get 0.33. Either one of these is acceptable. They are both good. Both of them are great. So, just pick one way to do this. If you did it by hand, you probably got that. If you did it by calculator, you got this. Either way is fine. Both are correct. Moving on to the last one, we have 1 over 3 to the x, but instead of x, I'm going to put in a 2. So, boom, boom. I got 1/3 to the second power. If you did it by hand, you got 1 over 9. If you didn't, you should have 0.11. Like I said, either one is correct. It just depends on the way you did it. All right, so let's take these and we're going to graph them because we now have a table. So same way we did it last time, we are just going to take our x values and pair them with the y values. So I got -2, 9. I got -1, 3. I got 0, 1. 1, 0.33 or 1/3. And then 2, 0.11 or 1 over 9. Okay, taking these pairs, we are going to put those on our graph. So, let's see what we got. Starting with the first one, I got -2, 9. So, gonna go down here. I have my x and my y axis. I want -2 on the x, and then I'm gonna all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. All the way at the top. First point done. All right, let's do the next one. We got -1, 3. So I'm going to go over to -1, up 1, 2, 3, right here. Boom. All right, next one, we got 0, 1. So, gonna start at 0 and then just go up to 1 right here. Next one is 1, 0.3. So remember, if you have that decimal, we're gonna approximate. So I'm gonna go over to 1 and then up. I think it's gonna be around here somewhere. Somewhere around there. I think that's about 1/3. All right, and then the last one we have is going to be 2 to the 0.1. I think that's going to be, well, I know it's going to go over 1, 2, and then I think it's going to be like right here, like just above our line, because it's really close. So I'm going to go right there. Okay, that's all of my points. So I'm going to connect them like so. I'm going to make sure that this goes off of my graph and that my line does not touch that asymptote, because once again, we're getting really, really close to 0. We had 9, and then we went all the way down to 3, then down to 1, down to 0.3, 0.1. We'd probably go past that to like 0.01, like super close, but we're not actually going to touch that 0. So that's where my asymptote is. All right, so let's fill out our characteristics. First one, is this growth or decay? Let's see, we started out really, really high, and then we went down really low. So from high to low, that's going to be decay. All right, our asymptote, we said that was right here, right at this line where 0 is. So asymptote is going to be y equals 0. All right, let's take a look at our y-intercept. This is my y-axis. Where does it hit? Right here. That's at 1. So my y-intercept is 1. Domain. Domain is going to be the same thing every single time. Our domain is big enough to be all real numbers, or ARN, every time. Now we just need to find our range. So let's look at this. Our range, it stops here at our asymptote. So we know we're going to be there. And then this is on the top half of our graph. It's still in the positives, even though we decayed. We're still in the positive half of the graph, not on the negative part. So we are going to have y is greater than 0 for our range. And that is numbers 7 and 8. You are going to go through the same process for all of these problems. You're going to have to build your table, graph it, and then fill out your characteristics. So be careful with these other ones. We're not going to do them together. We're going to do some of it in class. But some of these are a little bit more complicated than what we had here. For these two problems, all we had to do was multiply. This one is multiplying and it has a -2 on the end. So make sure you're putting that whole thing into your calculator or making sure you're incorporating it when you're doing it by hand. You want all of these pieces to be in there. So for number 9, our first one, we would have 3 to the x minus 2. But instead of x, we're going, instead of x, we're going to put in the -2. You need to figure out this whole thing, not just this part. You got to do the whole bit. All right, so I left these ones up to the students to finish. Like I said, we're going to work on some of this later in class as well, but these last ones I left for you. All right, that is the end of my notes for today. We are going to practice this quite a bit more in class, but let me know if you have any questions. That's all I got. Bye.